Section 10.1 Characteristics of Gases. In many ways, gases are the most easily understood form of matter. Even though different gaseous substances may have different chemical properties, they behave quite similarly as far as their physical properties are concerned. For example, we live in an atmosphere composed of a mixture of gases that we refer to as air. Air is a complex mixture of several substances, primarily nitrogen, oxygen, with small amounts of several other gases, including argon. We breathe air to absorb oxygen, which supports human life. Air also contains nitrogen, which has very different chemical properties from oxygen, yet this mixture behaves physically as one gaseous material. Only a few elements exist as gases under ordinary conditions of temperature and pressure. The noble gases, helium, neon, argon, krypton, and xenon, all are monoatomic gases, whereas hydrogen, nitrogen, oxygen, fluorine, and chlorine are diatomic gases. Many molecular compounds are also gases. Table 10.1 lists a few of the more common gaseous compounds. Notice that all these gases are composed entirely of nonmetallic elements. Furthermore, they all have simple molecular formulas and therefore low molar masses. Substances that are liquids or solids under ordinary conditions can also exist in the gaseous state, where they're often referred to as vapors. The substance water, for example, can exist as liquid water, solid ice, or water vapor. Gases differ significantly from solids and liquids in several respects. For example, a gas expands spontaneously to fill its container. Consequently, the volume of gas equals the volume of the container in which it's held. Gases also are highly compressible. When pressure is applied to a gas, its volume readily decreases. Solids and liquids, on the other hand, do not expand to fill their containers, and solids and liquids are not readily compressible. Gases form homogeneous mixtures with other regardless of their identity or relative proportion of the component gases. The atmosphere serves as an excellent example. As a further example, when water and gasoline are mixed, the two liquids remain as separate layers. In contrast, the water vapor and gasoline vapors above the liquids form a homogeneous gas mixture. The characteristic properties of gases arise from their individual molecules are relatively far apart. In the air we breathe, for example, the molecules take up only about 0.1% of the total volume, with the rest being empty space. Thus, each molecule behaves largely as though the others were not present. As a result, different gases behave similarly, even though they're made up of different molecules. In contrast, the individual molecules of a liquid are close together and occupy perhaps 70% of the total space. The attractive forces among the molecules keep the liquid together.